Alright guys, I'm going to try to talk as loud as possible just because I don't have my microphone right now. But we're going to pick up where we left off in class. So in class, remember, we were looking at this equation and we identified that A, the amplitude was 3, the period here is 2 pi over the absolute value of B, which is 2 pi over 4 because that's our B value, and that was pi over 2. Our phase shift is pi over 4 to the left, because remember, you have to take into account that B when you're talking about the phase shift, so it's going to be your H divided by your 4, and then we don't have a vertical shift. Alright, so when it comes to graphing, the first thing that you should do, the first thing you should do is identify the vertical shift. This should always be the first thing. Now in this case we don't have a vertical shift, so our graph is kind of staying exactly where it is through the center. But what's different here is the second thing. The second thing you're going to graph is, before I do that, so because we don't have a vertical shift, that means the middle of the graph is going to be this midline. I know you can't see it over the green, but I am drawing a midline in the center. And from this midline, I'm going to identify my amplitude. So because my amplitude is up 3 and down 3, so I'm going to go up 3, and I'm going to draw the line where the graph is going, and down 3, so I'm going to draw a line where the graph is going at the bottom. And that will show our amplitude, so that our graph is actually going to be that big. Alright, after this point, basically what you want to draw is, you know that from 0 to pi over 2 is going to be one period. Right? Because we figured out our period to be pi over 2. So what that means is that the sine function at this graph is kind of getting smushed down, because the original, cosine function would have looked like this. It would have, everything would have shifted. I don't want to draw this out completely, but without the period, it would have started up here, it would have gone down through pi over 2 just like it always does. It would have gone down to pi over here. Okay, I'll just kind of show you a rough sketch. Oh, you can barely see that, but it would have started up here, gone down, and still made all the way up here, that cosine function like it always does. But what that period does to it is it basically says, okay, originally the cosine function starts at 1, but because of the amplitude it's actually going to be starting up here, and it's going to actually be ending at pi over 2 instead of 2 pi, which is the original period. So at pi over 2 it's going to end, and if you remember, cosine, looks like this, and it would have ended at 2 pi if the period was 2 pi, but because the period is pi over 2, it's going to end at pi over 2 up here. And then the middle point, which is pi over 4, is going to be our trough, okay, our lowest point, which is all the way down here. So I'm just going to draw this rough sketch, okay, and then if you wanted to basically repeat that, you could. So every pi over 2, it's going to go, it's really ugly graph right now, I know, but you can kind of see what it's doing, and that is going to be your cosine function all the way through. Alright, but we have one more thing that this graph does. and it is the phase shift. Always leave the phase shift to the last. I actually suggest doing exactly what I just did, which is identify the vertical shift. If there is one, draw your midline at that point. Identify how high and low the graph goes. Mark your period, and that's where your graph is starting and ending. And then the last thing you're going to do is the phase shift. So because the phase shift is saying that this whole entire graph is moving to the left pi over 4, that's all you have to do is move every single one of these points to the left pi over 4. So instead of this point, it's going to be right here. And then this point is moving right there. And this point is moving over 1. This point is going to be moving over 1. This point is going to be moving over pi over 4. So now when I graph this, and actually now I can okay, and that is going to be my graph. And the period is still from 0 to pi over 2. Alright, moving on to the next example. So the next example, before I do anything, I'm going to look at this function, and basically what this function is doing, you notice that the minus 3 is on this side. So what we have to do is rewrite it. So we rewrite it as 3 sine of 1/2 x, but instead of putting the minus 3 on this side, I'm going to write it on the other side, so minus 3. I didn't change the sign because I'm not moving it.
Matthew wants to watch a Minecraft animation. Minecraft, like real life Minecraft.
Alright, that's fine.
Sorry to interrupt you.
Okay, excuse that interruption. So now let's identify the amplitude. So the amplitude here, again, is 3. Our period, since it's a sine function, it's going to be 2 pi over the absolute value of b. And in this case, b is going to be the 1/2. So it's going to be 2 pi over 1/2, which of course is equal to 2 pi times 2 over 1, which is 4 pi. So this period means that the graph is actually going to be a lot bigger than the graph that I have right here. So this is going to pose a little bit of a problem, but we'll change these up a little bit. Alright, now in this case the phase shift, there is no h, because remember this is the minus 3 that was not with the x. This is the minus 3 that was on the outside. So there is none. And then the vertical shift here is down 3. Alright. So this is going to be a little hard to graph on this function right here. So what I probably will be doing for you guys on the quizzes is giving you this graph but without these numbers, and then you can just kind of fill them in as you need to. Because for this problem specifically, I'm actually going to have to extend this graph down to -3, -4, -5, -6. And then these numbers right here are actually going to have to be 2 pi is going to have to be right here, and then 4 pi is going to be right there. So we're going to have to ignore these numbers for a second. Alright, I'll explain why I did that. But basically, because the period is 4 pi, that means this function is going to be stretched out so that the end of it is at 4 pi. All right, so like I said before, the first thing you want to do is, first of all, identify the vertical shift. So originally sine functions start at 0, so vertically they're going to shift down 3, so 1, 2, 3. So that means my midline for my whole entire function is going to be at -3. And then from this, I identify the amplitude. The amplitude is 3, so this is the middle. So the amplitude being 3, that means I'm going to go up to 1, 2, 3, so my graph is going to come up to 0, and it's going to go down to 1, 2, 3 to -6. Alright, and this is actually not that difficult. The only thing that's really changing is that all of the points from your original sine function now are just going to be moving down 3. And the only difference is that instead of ending at 2 pi, your last point that would have been at 2 pi is going to be at 4 pi. So if I just do a quick little sketch of the sine function, this is sine, and then it goes up to 1 at pi over 2, and then down to 0, and then at pi it's down to -1, and then comes back up at 2 pi. Oh, I just completely messed that up. But the function looks a little bit like this, where the period does end at 2 pi. Okay, and this is pi over 2, that's what the mistake was. Oh, I'm sorry, this was pi. Ugh, I don't know what's wrong with me right now. Anyways, but that's the function. So now the only difference is that this is just going to move down 3, and it's going to stretch out. So instead of starting at 0, we're going to start at -3. Okay? And instead of ending at 2 pi, I'm also going to have my 0 at 4 pi. But remember, now my zeros have all shifted down 3 points. So my zeros are going to be at -3. Okay? And because I know my graph is going all the way up to this line because of the amplitude, halfway through between 0 and 2 pi, so pi is like right around here, and then you connect that, you go back down, and then we know that this guy is going to come all the way down here at 3 pi, and then it's going to come back up. And that's it. That's basically my graph. I mean, once you identify how much you're stretching it out and how much you're stretching it this way, it's just moved. Really the hardest thing to do is the phase shift. So I always suggest to graph this first, but in this case there is no phase shift, so we don't have to worry about it. Alright, let's try one more. Well, two more actually. Alright, so here, again, remember you see the -5/2 is on this side, so I'm just going to move it over here, but instead of making it a 5/2, I'm just going to move it over as a 2.5. So this is going to become y equals cosine 3s minus pi over 6. It's a negative, okay, so it's going to come as a negative 2.5. And that's just going to make it easier for me to really understand how much I'm moving up or down. Okay, so here, our amplitude. Because there's no A, our amplitude is just going to be 1. All right, our period. Now you notice that usually the B is right next to the S, but in this case the B has been taken out. So you need to remember that this can also be distributed back in, okay? So this is your B value. So our period here, because its cosine is going to be 2 pi over absolute value of B, so it's going to be 2 pi over 3. So the graph is shrunk a little bit. All right, our phase shift. So in this case, usually what we do is we take our pi over 6 and we would divide it by whatever our b is, but our b has been already removed. So because it's been taken out, then our phase shift is just pi over 6 to the right because it's a negative here. And then our vertical shift is down 2.5. Alright, so again, this graph is going to look just a little bit funky. Alright, the first thing I'm going to start with is I'm going to identify my vertical shift. So originally I know that cosine functions, where do they, they're centered at the midline. And usually the lowest is -1 and the highest is 1. So if everything is going to be moving down 2.5, my midline is going to be at 1, 2, 2.5. Okay, so if this is 3 right here, so 2.5 is kind of right in the center because it's going down. So this is the midline because the midline is usually always at the 0. All right, our amplitude is 1. So from this midline, it's going to go up 1. And then from this midline, we're going to go down 1 to -3.5. Alright, so now I know my graph is going to be approximately, all my points are going to be in this area right here. Alright, next off I'm going to, I need to mark off my period. Now again, because this has been pre-marked, it's a little bit hard to graph this. So if this was not pre-marked, then what I suggest doing is changing, writing in, so making it pi over 6, and then maybe skipping one even. Or we can do 2 pi, yeah, I would skip one and say this is 2 pi over 3. I know this is messy, but we'll go over it again tomorrow. So I know my period is 2 pi over 3, which means my cosine function is basically going to repeat in between this section right here. Alright, before I even think about my phase shift, I'm going to graph the cosine function as it would be in here. So originally, if you remember, the cosine function does not start at the midline, it starts above, and it ends usually at 2 pi. It's going to end at the top as well. And then this in the middle, we are going to have our middle, basically, our trough. So this is one period. Okay, and I can keep going. I can keep going and graph this completely. Alright, but I need to remember I'm not done yet because I do have a phase shift. And this phase shift is telling me that every single one of these points, and this was a mistake, but every single one of these points is going to be moving over a pi over 6. So that means that this point is going to move all the way to pi over 6. This point is moving to pi over 6. And this point is moving to pi over 6. Or it's not moving to pi over 6, it's moving pi over 6. So my actual graph is right there. And then you can continue graphing, but I know that this probably confused the crap out of you guys right now. But we'll talk about that tomorrow. It's just, I wish I would have put a blank one. Alright, so this green is basically one period, because all you have to do is graph one period of this function. Alright, we're already 20 minutes in to this video, and there's really only one example left. So why don't you guys try to do this example on your own, and then we will check it tomorrow. Now I know on your sheets you guys have better graphs. Alright, good luck.